Okay, welcome back once again. This is Jeff Woods from itelescope.net, ADB Jester on Flickr and on Facebook, and this is part 3 of processing my Cygnus Panel 1 mosaic demonstration of how astrophotos take shape. We had just finished integrating the hydrogen alpha into our image, and we were left with this in Photoshop. Before I move on to integrate the oxygen 3, I want to talk a little bit about the color theory here so that I'm not confusing you with terms like hydrogen alpha and oxygen 3. So what exactly have we captured with our camera here? Well, we use filters over the cover of a black and white camera, and the red filter lets in only the light between about 625 and about 700 nanometers, that wavelength of light, from about this orange over to, well, let's see, from 625, so from about here over to about here. That's the imaging red filter, that line right there. And the green and blue filters overlap a little bit, but the green filter is about a little less than 500, so it starts down here in the teal and comes up to about 575 just as it starts to turn yellow. And the blue, of course, starts at about 525, so it starts in the teal here as well and goes down into the deep blues near purple. And those are the three images that make up our RGB, the red, green, and blue image that we started with. So what are hydrogen alpha and oxygen 3? Those are referred to as narrowband filters, and there are three main ones. There's hydrogen alpha, which is just that tiny little sliver, that line right there between 674 and 678 nanometers. And the reason it's so narrow is that is the range of light that's emitted by specific activity in hydrogen atoms in clouds. When hydrogen atoms, electrons, move from orbiting shell to orbiting shell, they give off light, and they give it off only in this very narrow range. And since hydrogen is the most common element in the universe, there's an awful lot of hydrogen alpha emitted out there, especially in clouds of hydrogen and star-forming regions and nebulas. The second most popular narrowband filter is oxygen 3. Oxygen is also a very common element in the universe, and it's this tiny little sliver of blue-green, this teal, right here about 504, I think is the exact number. I'm not sure off the top of my head. And sulfur 2 is another popular one. It's a deeper red, but there's not as much sulfur in the universe unless you're imaging strictly in narrowband. If you're not going to do red, green, and blue, if you're only going to do H alpha, O3, and S2, then you'd probably do the S2. There's also a blue that's hydrogen beta down here, but it's also not as popular. But that is why we image these, and what happens is we take only 5-minute exposures of the red and the green and the blue. But when it comes to hydrogen alpha, because we're limiting the light that comes through to this tiny little sliver, we take very long exposures. And in our case, we took 20 exposures of hydrogen alpha. We only took 7 of the red, but we took 20 hydrogen alpha, and we took them at 15 minutes each. So we have 45 minutes of color data, but we have 5 hours of hydrogen alpha data, and that's one reason we want to use the H alpha as our luminance, as our sharpness, crispness, and detail, because it's much cleaner data. We have a lot more of it. The oxygen 3 we shot for 600 seconds, and we shot 6 frames of those. There's not a whole lot of oxygen 3 in this region. If it were a brighter region, we might have shot more. But this is just enough to give our blues and greens a little bit of boost. Because when you shoot 600 seconds, you're going to get a very much more specific and clear response from your filters. So that's what we've done. And in our Photoshop image, if you'll remember, if we step back a little bit, I can't step back because I've closed Photoshop and reopened it since, but if you'll remember what the RGB looked like, it didn't have near this amount of red in it. And let me bring that back up for just a moment and make it smaller, because I want you to compare that H alpha red to the H alpha blend that we got here. We're a little bit darker, but we're pretty close. It's actually closer to a sulfur 2, so this could have been a little bit brighter. But again, remember, this is all artistic interpretation. These things can't be seen with the naked eye. They don't really have this color. This is all hypothetical and theoretical. We're well into the realm of art here, so we want to make it look as pretty as we can and still be at least somewhat or marginally true to the colors that it would be if we were able to see it with the human eye. So I think we've done a pretty good job of getting this deep red, especially up in here. It's not a bad representation of hydrogen alpha. So now that you understand a little bit more about what hydrogen alpha and oxygen 3 is, let's move on and add the oxygen 3 to this the same way we did with the hydrogen alpha. So we're going to do pretty much the same thing. However, we're not going to deal with two different versions of the oxygen 3 as we did with the hydrogen alpha. The hydrogen alpha will be our luminance image. The oxygen 3 is only going to be used to boost the green and the blue channels. So, well, here, I do have that image. That's, oh, no, I don't. Okay, so we're going to take our oxygen 3. Now, I've already done the stretching on this. And that's what it looks like. If we zoom in here, you'll see that it's quite a bit noisier than it was in the hydrogen alpha. It's very grainy, and that's because our signal here isn't terribly strong. We only have 600 seconds versus 900 seconds of data, and there's not nearly as much oxygen 3 emission going on in the region. So to get even this much detail out of it, I had to stretch a signal that wasn't really there an awful lot. So one thing we might want to do is run some noise reduction on this before we blend it in. Because remember, this is only going to be color, so it doesn't matter if we lose a little bit of the detail in it. So I'm going to run Noise Ninja on this and just let it do its thing normally. Here's Noise Ninja, and I'm going to get down in here into the cloud and look at the difference. That's before and after, before and after. And that's going to clean that up quite a bit. So I'm happy with the defaults there. I'll just let it do its thing. Now we want to go into our color image. And as we did with the hydrogen alpha, we only want to work with the green data. We're going to select all of the green data and copy it to the clipboard. We're going to turn off that annoying sound. We are going to go back to our scaled, stretched oxygen 3 data and paste our stars over the top of that. And change the blending mode to lighten, so we have our oxygen 3 cloud and the stars from the original blue layer of our color image. And we flatten it. We copy it to the clipboard and we paste it back into the green. I'm sorry, it was the green channel we started with. Now look at your little thumbnail up here. I'm not going to show, well, let's show you what it looks like. Oh, gave us a really strange orange tint in this area here, and it turned our stars green. We can see a really big green haze up here too. That doesn't look very good, but we're not done. Oxygen 3 is not green, and it is not blue. As we discussed, it's kind of a greenish blue. So not only do we need to add it to the green, we need to add it to the blue. So let's go back to our oxygen 3, and in Photoshop, let's step back and take the blue image and copy it to the clipboard and paste it into our stretched oxygen 3 data here. And again, setting the blend mode to lighten. And now that is our original oxygen 3 that's our original blue channel. And that's the blue channel with oxygen 3 enhancements. So let's flatten those, copy that to the clipboard, and go back to our blue channel here and paste that in. And now let's see what that did to our RGB. Oh, yes, that looks much, much better. In fact, that looks an awful lot like a very famous known image from an imager called Rob Gendler. And he was the inspiration for my taking on this project. Now again, I've only started here. I've only started to blend in the color, and I haven't done any of the processing to clean up the stars or the halos or to enhance the detail. But we're on our way to some pretty good looking color, because here is Rob Gendler's version of that region. So there's ours, and there's Rob Gendler's. So we're really on our way to coming up with a very nice image of this region. And now that our oxygen 3 is in, we can go back to red, green, and blue. And one of the things we can start to do now is clean up the color. We can run the Hasta la Vista green filter. And it takes that greenish tint out of all of our stars. So hasta la vista, baby. And that makes our stars look a whole lot better. And it got rid of most of that flare around that star, which I erroneously said was caused by the fluorite in the optics in the last video. It's actually caused by reflections in the camera neck, in the I forget the technical term for it, but it's a reflection of that star in the camera optics, and there's not a whole lot we can do about it. It happens more commonly in blue and green. About all we can do is go in here and change the color and clone it out. That's why it's off center a little bit, because it's a reflection coming from the side of the camera into this. If this star had been, say, over here, it'd be off center the other direction. Only if the star was right in the middle of the image would the reflection be perfectly centered on the star. Okay, now as we discussed before, we've got this very busy star field. We've got a great deal of nebulosity, and that's really our attention's being taken away from it by all of these stars. There's so many stars here that these thin wisps up here we can barely see, and the good wisps down here, we're just having a hard time seeing anything. So how can we remedy that? This is where using hydrogen alpha as luminance comes into play. What we're going to do is quite literally take all of these stars out of the image. We're only going to keep the nebulosity. And when we do that, we're going to blur the image just a little bit so that any remnants of the stars are taken out. Because remember, the color doesn't add any sharpness or detail to it. It's just color. So it doesn't matter if it's very blurry, because the detail comes from the luminance, or the uncombined hydrogen alpha. So the way we're going to do this is, before we start using other techniques, we're going to make these stars as small as possible. And Noel Carboni has a Photoshop action make stars smaller. Now, in reality, it is just a very long list of functions that are very close to what we're going to do later. We're going to use the minimum filter to take the stars out a lot more harshly, but we want to make them small nicely. And the interesting thing about Noel Carboni's make stars smaller function here is that if we make a star smaller, it's going to pinch the color of the nebulosity into the star. It's not just going to make it smaller and leave a dark ring around it. That's something we want to avoid. We don't want to leave any artifacts behind. So let's go ahead and do that. Now you'll notice that I've made a copy here, so I can look at them before and after just by turning on and off the layer. They are before and after, before and after. And I'm going to just keep making copies and keep making them smaller until I think that they have been reduced sufficiently that we can bring in the hydrogen alpha as luminance after blurring the rest of the stars out. Okay, there's 2 iterations of Noel Carboni. Original and now. And look how it's pulling those stars, pulling the nebulosity in close where it made the stars smaller. Let's go ahead and do it again. Okay, there's 3 iterations. Before and after. Before and after. Now we're never going to get rid of them all, but we're going to get rid of them pretty much as well as we can. Let's run that a 4th time. You can already see that they're disappearing quite nicely, but we need to keep some color in these stars. We don't want them to go away entirely. I'm starting to see a little bit of an artifact around the stars. Do you see that? A little bit of a dark ring. There's not a whole lot we can do about that. It pulls as much color in as it can. That's why we're going to blur this later. Let's take a look at this. Well, you can see we've really started to see the color behind the stars, but those stars, when run through 4 copies or more of Noel Carboni's tools, really aren't very good stars. We'll have much better stars if we replace those stars with stars from the hydrogen alpha that comes from that came from our original black and white. So let's see what a 5th run looks like. Yeah, see, we're getting a lot of artifacts there. That's a 4th. I don't think we can go 5. I don't know. Let's see. Yeah, I'm not sure we can go 4. Yeah, I think that's as far as we're going to go. I'm going to take these 2 layers and just trash them. And we'll go back to that. Now that our stars are a little bit smaller, I'm going to do something that's a much stronger version of what Noel Carboni is doing. And I'm going to go straight to the minimum filter. And that's going to take out almost all of our stars. Now it's going to leave the brightest ones behind, and that's good. That's going to leave color behind for those stars. Now that might still be a bit much. It's still a little mottled in there, but our blur will take care of that. But, oops, what happened? Why can't we fade that? Why can't we fade that? Okay, let's see what's going on here. Oh, my minimum filter is still up. Now I could be even more aggressive with that. 1 pixel is as little as we can go, but watch what happens if we go a lot. We start getting very pixelated. We get black splotches. We don't want that. We want to keep as much detail as we can here because we want those wisps to color in correctly. Look at all those white artifacts there in the star field. We can take care of those. Okay. Yeah, see all of that? I think we can get those a little bit taken care of. Let's run one more filter on this called Dust and Scratches. And let's run it only at about 3 pixels. Yeah, 4. 4 looks like it's doing better. And that has really taken out some of the white modeling of our sky background, but it's still left behind enough of the color for the stars. And it's got all of our detail in the wisps, and those black blotches have gone away. So before we do one more thing, let's do the blur I talked about. Let's do a Gaussian blur. Now that is just way too much, but that's 115 pixels. We don't need to blur it near that much. Even 40 is too much. Even 4 is probably going to be too much. Well, 4 doesn't look... Well, let's see. That's before and after, and that smears it around even still too much. Let's try just 1 pixel. Before, after, before, after. That's just maybe 1.5. Yeah, that smooths that color out just enough that when we take our luminance and paste it back over it, we're going to be good. Now would be a very good time to come in here and clean up these halos. This artifact around the star, the reflective artifact, and there's a couple down here around the blue stars, the brightest blue stars. So we're going to do that before we paste our luminance over the top of this. So you have to wonder, we did all that work to get that image nice and bright and crisp and clean, and now we've done some really horrible things to it, but that's to be expected. Let's go ahead and we'll get there, I promise you. Let's go ahead and zoom in on this and figure out how we can darken that down into red. One of the things we need to do is we need to work only on that region. So we're going to select by color range, and we're going to select based on sampled colors. So we're going to pick that pixel, and then we're going to add everything around it that we can find. Not the star, but the halo itself. We want a whole big range. Now look, we can see it's getting the star here, but it's also picking up a lot of other stuff out here. But that's okay, because we're only going to work on this region. And you'll see how we do that in just a moment. Oh, wait a minute. That's not going to work. We have to make another copy. And I'll explain that in just a minute. Now we can select our color range. We're going to pick one and add a bunch more. I'm just clicking on everything I can here, all the way around the star. Get everything right out to the region. We don't want to click on the red because we don't want to affect the red. We want to affect everything that's in this halo but outside the actual star itself. And you can see, if I zoom in on that, well, I can't zoom in on that, but you would see that I've picked up almost everything in a donut right around that. So let's go ahead and tell it, go ahead and select that. And look at that. The star is not included, but everything in here is. Now what else did we capture? Well, we captured a lot of other stars. We didn't capture our problem blue stars. But we did capture, and look at this one. This one seems to have a bit of a bit of that, but that one's not bad. So let's first work on that star. Let me zoom over to it, and then I'll show you how we limit the work to that star. So what can we do here? We don't want to change the detail behind it. There's some nebulosity that pinches in here, and it's darker and lighter up there. We also don't want to have a hard edge to what we've done here. So I'm going to expand this selection by just a little bit, just like 4 pixels. 4 pixels is good. And then I'm going to feather it. I'm going to make it fuzzy, a slight change of just 2 pixels, about half of what I did. So now you know what, I don't like that. I'm going to expand it by 2 pixels and feather it back by 1. Okay, so now how can we change this color into that color? Well, we can try to do selective color, and we can try to add okay, we don't want to be working on the reds. The reds aren't the problem. Problems are cyans, are greens, the colors that are interfering with that filter. Let's take the cyan out of the cyans, put the magenta in, yeah, that's not it. It's a lot of experimentation here. It has nothing to do with the magenta in the cyans, nothing to do with the yellow. What about our greens? Is this mostly green? No, it has nothing to do with that. It has nothing to do with the greens. So where are we? We at the blues? Nothing in the yellows. Wow, I can't figure out which one of these it is. Some of these should be affecting those, and it's not. How about the magentas? Can we bump the magenta? No. Is it yellows? Well, part of it's the yellows. Well, another way we can do this, because I don't think we're getting very far with that, is we can do selective curves on individual colors. We can go into the green channel and bring the greens down slightly. We can go into the blue channel and bring the blues down slightly. Let's see what, well, that's the region we need to bring them down, right there. So let's bring the blues down there. That's a little better than it was before. And we're still a little purpley around the outside edge. That's certainly better. I wonder if we're too much there. No, that's very green. All right, let's see what... might want to come down a little bit more on the green. Okay, how about intensity? Can we just bring down the intensity? Because the color looks like it might not be bad. Can we take that a little bit darker? Well, all right, we're going to take the greens. Well, there's no greens in there. We're going to desaturate the greens. Turn them down a little bit. Now the greens aren't doing much. What is it? Yellows. Okay, it's not the yellows. Magentas. You get the idea. I'm going to pause and finish this, and then we'll come back in part 4 and add our luminance layer.